Hello everyone, in this video we are going to discuss a famous topic in differentiation which is known as chain rule. What's that? By the time we know that ddx of sin x is my cos x, and we also know that ddx of log x as 1 divided by x. Now if I will ask what is ddx of sin log x, for the very first step, if I assume that log x as z, the sum will be ddx of sin z. Now z is a function of x, so we can write ddx of sin z as 0. So what I can do, I can differentiate this with respect to z, and then I can multiply this dz over here and this dx thing is there. So this dx thing is here and this dx part we are just using it to differentiate sin z. So now what will be ddz of sin z? From this formula we can write ddz of sin z as cos z, and this one will be ddx of this function z. What was my function z? That was log x, and ddx of log x, as we know, that is 1 by x, it will be cos x by x. The same sum, if I will write that ddx of log of sin x, what will happen if I will write ddx of log of sin x? Any idea? So first I will assume now z as sin x. So as z is my sin x, I will write ddx of log z. Similarly, we can differentiate log z with terms of z only. So I will write it as ddz of log z into dz dx, right? So ddz of log z, that will be 1 divided by z, right? Into ddx of z, which is sin x, 1 by z, that is 1 by sin x into ddx of sin x is cos x. So answer is cot x. So first you have to identify which function you have to differentiate, first one. Next, ddx of e to the power x, we know e to the power x. ddx of tan x, I know, sec square x. ddx of log x, I know, is 1 divided by x. If I will ask ddx of tan of e to the power x, just check. Now I am going to do chain rule just in one line. First, ddx of tan x, that we know, sec square x, right? So ddx of tan e to the power x, that will be sec square e to the power x into ddx of e to the power x. ddx of, again I explain, ddx of tan x, we know, sec square x, then ddx of this e to the power x, and ddx of e to the power x, you know, e to the power x, sec square e to the power x, right? E to the power x, this one is coming as e to the power x. If I ask ddx of e to the power tan x, just check first. ddx of e to the power x, ddx of e to the power x, formula is e to the power x only. So it will be e to the power x into ddx of tan x, and ddx of tan x is sec square x. So answer is e to the power tan x into sec square x, right? You need to practice this a lot. I am going to discuss some more example on chain rule right now, but as you know, always you can ask me problem in the comment box so that I can solve it for you. ddx of sin x square and ddx of sin square x. How to solve these two? First, what is ddx of sin x? Cos x, right? So ddx of sin x square, you can write cos x square into ddx of x square, and ddx of x square you know 2x, so cos of x square. ddx of sine square x, how to think about this? ddx of sine x whole square. What is ddx of x square? ddx of x square will be 2x, right? So ddx of sine x whole square will be 2 sine x into ddx of sine x, which is cos x. So it will be 2 sine x cos x, right? I will discuss one or two more problem on chain rule. It's very important. Please be very careful about this. We need it. Next one. Now I am going to use 3 or more functions in chain rule, like ddx of log of sine e to the power x square. I know it's huge, but we are going to do it in one line only. Just check. ddx of log x. ddx of log x is 1 divided by x, right? So it will be 1 divided by sine e to the power x square into ddx of log x, which one you have taken as x, right? Next one, ddx of sine x, that will be cos x, right? So next line will be 1 divided by sine e to the power x square, ddx of sine x will be cos e to the power x square into ddx of this portion we have taken as x, right? So if I will simplify this to part, it will give you cot of e to the power x square, right? Next one, ddx of e to the power x, that is e to the power x only, right? So it will be e to the power x into ddx of this x square, this portion will come. So ddx of x square, which will be 2x. And listen until we will complete with all the functions of x, this will go on. So this will be 2x ultimately. I am just writing it as 2x into e to the power x square into cot e to the power x square. I am just going to use the same functions just in some other order. Just check in the next sum. So next sum, if I am going to use ddx of like this, ddx of, previously I have used log of sine of e to the power x square whole square, or rather sine square e to the power x square. So for this one, first we have to apply ddx of, ddx of x square. This is my x now. ddx of x square, that will be 2x, right? So it will be 2x into ddx of x. Just check ddx of x square. I have taken this as x square, so I am writing 2x into ddx of that x. 2 sine e to the power x square into ddx of sine x. Which one you don't know, just assume this as x. ddx of sine x, that will be cos x, right? Cos x into ddx of x. So 2 sine e to the power x square into cos e to the power x square into ddx of e to the power x. The formula is e to the power x into ddx of x square, which is 2x. Now it's done, right? ddx of e to the power x square, e to the power x square into ddx of x square, that is 2x. So it is 2x into e to the power x square into another 2 is coming from here, sine e to the power x square into cos e to the power x square. If there is any other problem in chain rule, please do write me in the comment box. I will solve it for you. Thank you.